A transistor is an electronic component that acts like a valve to control the amount of current passing through it, much like how this valve on the faucet controls the amount of water flowing through the hose. A transistor has three terminals. One terminal brings current into the transistor, and a second terminal carries that current out. The third terminal is like this handle, and it's used to control the amount of current passing through those other two terminals. Now, unlike this handle, which I adjust by physically moving, we control the current through a transistor by using an electrical signal. Based on that electrical signal, I can have the transistor operating in one of three modes. I could turn the transistor so that the valve is completely open, and the current passes through it more or less unrestricted. This is known as the saturation mode, and the transistor is basically acting like a short circuit. On the other extreme, I could close that valve all the way to completely block the flow of current through the transistor. Now the transistor is operating in the cutoff mode like an open circuit. When I use a transistor to select between one of these two modes, either completely open or completely closed, I can use the transistor to switch on or off parts of a circuit. And computers are built of millions or even billions of tiny little transistors doing just that, switching on and off to represent ones and zeros of digital information. But a transistor doesn't just have to be used in either on or off modes. It can also operate in the third mode, known as the active region. When it's in the active region, it's as if the handle was somewhere in the middle. And in the active region, small changes to the amount of current at that input control terminal make much larger changes to the amount of current passing through the transistor. This allows the transistor to be used as an amplifier to take small input signals and make them much larger output signals.
There are two main types of transistors that you'll encounter: bipolar junction transistors, which are referred to as BJTs, and field effect transistors, or FETs. Although both types of transistors have three terminals, those terminals are given different names in BJTs and FETs because those two types of transistors have different physical structures. On a BJT, the terminals are called the base, emitter, and collector, and on FETs, they're called the gate, source, and drain. Conceptually, though, both types of transistors perform a similar function. The base terminal on a BJT and the gate terminal on a FET act like the valve handle on my faucet. They're used to control the flow of current between the other two transistor terminals. Now, the way that those two types of transistors are controlled is different. The amount of current that a BJT lets through is controlled by the amount of current into its base terminal, whereas FETs are controlled by voltage at the gate. But from a high level, they're both just electrically controlled valves that are used to regulate an external source of current. Since transistors have the ability to control the flow of current through them based on another electrical signal, they fall into a category of devices known as active components, which includes transistors as well as the more complex integrated circuit components like operational amplifiers, which are built using transistors. Active components require an external source of power to operate, and because they draw power from an external source, they can be used to amplify a signal, which means they can produce an output signal with more power in it than the original input signal. The opposite of active components are a category of devices called passive components, which includes resistors, capacitors, inductors, and even diodes. Passive components cannot be controlled by another electrical signal. They only respond to the voltage across them and the current through them. But, unlike active components, passive components can operate without an external power source. Although it's possible to build passive circuits containing only passive components that provide a voltage gain, meaning they increase or decrease the voltage of a signal, passive components cannot produce a power gain. The power out of a passive circuit will always be less than, or at the very best, equal to, the input power. Almost all circuits will include some combination of passive components, but they need to have at least one active component to be considered an active circuit. According to some definitions, for a circuit to be properly called electronic, it has to contain active components, controlling the flow of electricity. I tend to throw around the term electronic somewhat generously to describe both active and passive circuits. But active circuits really are what make electronics exciting.